Welcome to my presentation. I hope you all are doing well today. Good day, everyone. Today, I'm going to present a very interesting and important topic that is Introduction to Internet of Things, which is IoT. I am Samruddhi Bhatti from Department of Computer Science and Engineering. Before we begin, let me quickly explain what we'll learn in this presentation. In this video, we'll learn what Internet of Things is, what are the main characteristics of IoT, what are sensors and actuators, how an IoT system is designed, what are IoT protocols, what are IoT communication models, what are IoT communication APIs, what technologies support IoT, what are IoT levels and templates, and how IoT is used in different real world domains such as home, city, environment, energy, agriculture, and industry. Now, let's start with the introduction. In this slide, you can see smart and connected devices. This image represents the idea of Internet of Things. Internet of Things means connecting physical objects like sensors, machines, and devices to the Internet. These objects can collect data automatically, share that data with other systems, and also perform actions based on the data. Some common examples are lights, smartwatches, smart cameras, and smart parking systems. To proceed further, we'll see definition and characteristics of IoT. In this image, you can see many devices connected to one cloud. This shows that IoT is a network of connected devices. These devices use sensors to collect data from the real world. The collected data is sent through the internet and proceed automatically. Very little human involvement is required. Now, let us look at the main characteristics. Connectivity allows devices to stay connected and communicate. Sensing allows devices to observe the data environment. Automation allows the system to work without manual control. Real-time operation means decisions are taken immediately. Scalability means the system can grow to support many devices. Intelligent decision making means data is used to take smart actions. Next is sensors and actuators. In this slide, you can see an Arduino board connected with sensors and a relay. This is small but complete IoT hardware setup. Sensors are used to collect data from the environment. For example, temperature sensors measure temperature, gas sensor detect harmful gases, and light sensors measures light intensity. In the lower image, you can see actuators. Actuators perform physical action in the real world. For example, motor rotates, relays switch device on and off, and buzzers produce sound. In simple words, sensors give input to the system and actuators produces output. Without sensors, the system cannot understand what is happening around it, and without actuators, the system cannot respond to the situation. Next, design of IoT system. This slide shows the complete design of an IoT system. At the lowest level, sensors collect real world data. This data is processed by a controller. Then, the data is transferred through the network. After that, the cloud stores and analyzes the data. Finally, the complete application shows the information to the user. So, the complete flow is from sensors to controller to network to cloud and finally to the application. Next is IoT protocols. In this slide, you can see different protocols connected with IoT devices. Protocols define the rules for communication. They help devices to send and receive data correctly. IoT protocols are designed to be lightweight so that low power devices can use them easily. Some common protocols are MQTT, COAP, and HTTP. These protocols make communication reliable and efficient. Nextly, IoT Communication Models. In this slide, you can see four different communication models. In the first image, devices communicate directly with each other. This is called device-to-device communication. In second image, devices communicate directly with the cloud. This is called device-to-cloud communication. In third image, devices communicate through a gateway. This is called device-to-gateway communication. In last image, data is exchanged between different cloud systems. This is called backend data sharing. Nextly, we'll see IoT Communication APIs. In this slide, you can see gears connecting different systems. This represents API. An API allows software application to communicate with the IoT system. It is used to send data to devices and receive data from devices. APIs are very important because they help mobile application, web dashboards, and other systems work with IoT platforms. They make development faster and system integration easier. Next is IoT Enabled Technologies. In this slide, you can see wireless sensor nodes forming a network. This is known as a wireless sensor network. Many small sensor nodes work together and send data wirelessly. The collected data is then sent to the cloud. Cloud computing stores huge amount of data and performs data processing and analytics. Embedded systems are small computers inside IoT devices. They run software and control sensors and actuators. Together, these technologies form the backbone of modern IoT system. Next is IoT levels and templates. This slide shows different levels of IoT system. IoT levels describe how simple or complex an IoT system is. Templates provide standard and ready architecture patterns. Level 1 consists of only device and sensor. Level 2 adds gateways and connectivity. Level 3 adds cloud services, and data analytics. Level 4 represents complete smart solution that integrate many systems. These levels help designer choose the correct architecture and plan the system efficiently. Next is domain-specific IoT applications. This slide shows different real-world application areas. In homes, IoT is used for smart lighting, smart locks, and security cameras. In cities, IoT is used for traffic management, parking system, and street lighting. In environment monitoring, IoT is used to measure air quality, water quality, and weather conditions. In the energy sector, IoT is used for the smart meters and energy management system. In agriculture, IoT is used for soil moisture monitoring, crop monitoring, and smart irrigation. In industries, IoT is used for machine monitoring, fault detection, and predictive maintenance. To conclude my presentation, IoT connects the physical world with the digital world. Sensors and actuators are the heart of every IoT system. Wireless sensor networks, embedded system, and cloud computing support large-scale IoT solutions. Today, IoT plays a very important role in improving efficiency, safety, and decision making in many real-world domains. Thank you very much for watching my presentation. I hope this presentation helped you to understand the basics of Internet of Things.